SQL, an analytics staple. SQL is essentially a coding language, usually written as a query. It can be used to create tables as well, but a SQL query is made up of several statements that specify which data to pull, what tables to pull that data from, and how to organize that data. In the end, running a SQL returns a table of rows and columns similar to a worksheet in an Excel workbook. There are different parts of a SQL query, like the select statement, the from statement, where statement, group by, order by, and more. And we'll get into those when we look at the SQL session. For analysts and data scientists, especially at a level 2 or level 3 analytics maturity organization, again, SQL is truly a staple for data manipulation. And the proof of that is the fact that nearly every analytics platform has an option to write SQL code inside of it. That's true for Alteryx, SAS, R, Python, Tableau, Power BI, and more. Now, there are several different variations, slight variations of SQL, but the basic components like the select statement, the from statement, the group by the statement are the same across all of them. Just slight variations in things like date syntax and other aspects. Now, SQL has traditionally been ran on premises at a company and platforms like Microsoft SQL Server, Oracle, Teradata, and others. But over the last 10 years, big data cloud platforms have created their own versions of SQL, such as Snowflake, HiveQL, and others. This allows an analyst to use cloud computing to apply traditional SQL data manipulation, the same select, from, group by statements analysts are used to, in a way that can process billions of rows within seconds. It's quite impressive. I would say SQL is especially good at aggregating and grouping data. Nothing does aggregation like SQL does. It's also really good at joining tables together in a flexible way and creating custom columns. You know, in terms of data manipulation, SQL is very flexible. Although, in certain cases, when it comes to looping through data, platforms like Python, R, and SAS are perhaps even more flexible. But again, SAS can be actually ran, SQL can actually be ran within those platforms. Now, once a SQL query is written, it's normally used to pull some data, maybe one time, or scheduled another platform to run on a regular basis at a stakeholder's schedule or whenever on demand. It's very helpful for automation. When it comes to one-time data pulls, if you were to get an ad hoc data request, it's very likely that an analyst would go into a SQL platform like Microsoft SQL Server Management Studio, run the SQL query, copy and paste the results into an Excel workbook, and my recommendation would be to create a SQL tab as well that you copy over your SQL query there so it's all in one place, the same workbook, and then email that out to the stakeholder. SQL is often used for data manipulation, maybe some analysis as well. Most data science models, with the exception of things like market basket analysis, can't be used to create, most data science models cannot be created in SQL. But SQL is extremely helpful in creating the starting modeling data set for a data science model. So it is important, especially for the data engineering work involved with building a model, but it's not typically going to be used to actually run the modeling algorithm like regression or decision trees or random forests. Here's an example of a very popular SQL platform called Microsoft SQL Server Management Studio. And this is set up very similar to other SQL platforms where you can explore databases and data tables on the left in an Object Explorer. In the top section here, you can actually write your SQL statement. You have a select statement, a from statement, and group by statements and so forth that we'll learn more about. And essentially, you write the SQL query, press execute, which runs a SQL query, and eventually it'll result in a data table, a set of rows and columns, and you can copy that data to Excel or wherever it needs to go from there, or embed the SQL query in an interactive visualization platform, or in Python or SAS or any of the other analytics tools that have a SQL integration. I want to thank you for watching today. I hope you got a lot out of it, and if you did, please consider liking the video and subscribing if you'd like to see more videos like this in the future. Now, if you have any questions about what we covered, please consider leaving a comment, and I'll try to respond to it as soon as I can. One last thing, if you or your organization ever need anything analytics related, an analysis, a dashboard build, maybe a data science model build, perhaps deeper training on this very topic or other analytics topics, even a complete analytics transformation, please consider value-driven analytics. Check out our site at valuedrivenanalytics.com, and if it resonates with you, give us a call. We'd love to help you out.